Hey Julian, Mr. Anirban here, and I have uploaded the first of the 3 pages that you sent me for your homework. Now, before we get down to doing these problems, I'd just like to touch upon the equation of a straight line and with particular, stress emphasis on lines that are parallel to the x-axis and those that are parallel to the y-axis, because those are the types of equations that are kind of deceptive. You kind of get confused. I mean, where's the equation? So let me just draw an x-axis and a y-axis, label them as x and y. Now, in general, like I was telling you during our lesson, any straight line would be of the form y is equal to mx plus b. As an example, let's take y is equal to 2x minus 1. So clearly, as you can see, m is 2 and b is negative 1. Now it means that now we are saying this is an equation of a straight line. We need to understand why are we saying so. We are saying so because this means connect every point on the coordinate plane in which the y coordinate is 1 less than 2 times the x coordinate. So there's a point xy on the coordinate plane, right? Let's say this point. Now if it's y coordinate, this is x comma y. If the y coordinate is 2 times the x coordinate minus 1, then this point is on this line. And we can connect all such points. There will be a point here, there will be a point here. In fact, there will be an infinite number of points, right? And all those points are going to lie on the same straight line. So if we connect these points, what we get is a straight line. And because every point on this line follows this equation that for each point the y coordinate is 2 times the x coordinate minus 1, we end up saying that the equation of this line is y is equal to 2x minus 1. Now this 2 tells us it's actually the slope of the line. Now what's the slope? It tells us every time you increase x by 1, y goes up by 2. And it's actually very easy to verify that the slope is 2. So what you can do is you can come up with a table of values of x and y. So you have x on one side. Let's just avoid the negative numbers. Let's say, I mean, it would work with negatives as well, just trying to make the calculation simpler. So let's say x is 0, x is 1, x is 2. Let's just use these 3 simple numbers. Now when x is 0, this equation tells us that y is going to be 2 times 0 minus 1. That's negative 1. This is y. When x is 1, y is going to be 2 times 1. That's 2 minus 1. That's 1. When x is 2, y is 2 times 2 minus 1. That's 4 minus 1. That's 3. Notice that when x goes up by 1 each time, y is going up by 2 every time. So this is plus 1, this is plus 1, this is plus 2, this is plus 2, and so on. And like I said, this will work for negative numbers no matter what number you take. So we say the slope of this line is 2. What about this b? This negative 1 tells us, I mean, it's pretty easy to understand from this equation. It simply tells us that y is negative 1 when x is 0. When x is 0, then 2x or mx or whatever this is, when x is 0, this quantity is going to be 0. So y is equal to b. Now when is the x coordinate of a point 0? The x coordinate of a point is 0 when the point is on the y-axis. So basically this b tells us that okay, this line is going to cut the y-axis at the point 0 comma b. In this case, b is negative 1, so this point is going to be, the coordinates of this point is going to be 0 comma negative 1, and that's exactly what we see over here. It's this point. X is 0 and y is negative 1. So this is how you read the m and the b. And if the m is negative, it means the line is going to come down like this. So as x increases, y is going to decrease. That's to say that the slope is negative. If you look at this line, as x is increasing, if you are moving from here to here in this direction, On the x-axis, the numbers are increasing because you're moving to the right. And at the same time, as you're moving up the y-axis, the numbers along the y-axis are also increasing. So when x increases, y also increases. When x decreases, y also decreases. That means it's a positive slope. That's why we see a +2 over here. If this were a negative, the line would come down like this. That means if x is increasing, y is actually decreasing. Fair enough. So the equation of any straight line can be written in this form: y is equal to mx plus b. In other words, if you can express any equation in this form where the power of x is 1, then you know it's a linear function. Linear means along a straight line. So it's a linear function. Let me also write this term down. Linear function means it's a straight line function. And that can only happen when the power of x in the equation is 1. As you can see, this is just x, or x to the 1. There's no square root of x. There's no x squared. The moment you have those things, the function will no longer be a linear. It would mean that if you were to connect those points, that will not give you a straight line. Now, a little bit of trick is what happens to a straight line when it's parallel to the x-axis. So imagine we have a straight line that is parallel to the x-axis. There are two ways of looking at this. One is you could say, okay, it's a plane land. So as x is increasing, y is neither increasing nor decreasing. That means as per the definition of our slope, the increase in y, for every unit increase in x, well, y is not increasing. So then the slope of this line is 0. Visually also, it makes a lot of sense. This looks like a plain land. If this looks like a mountain or a hill that you're trying to climb, this looks like a plain land. And the slope of plain land is always 0. There's no slope at all. So then the equation, the slope of lines that are parallel to the x-axis is 0, which means that this quantity, this m is what? M is the slope. This quantity becomes 0, which means mx, this term becomes 0. So our equation looks like y is equal to b, where b is the y-intercept, meaning it's this point where the line cuts the y-axis. For example, if this point is, let's say 0, 5, then the equation of this line is going to be y is equal to 5. Because mx is 0, so y is equal to mx plus 5. So this becomes y is equal to 5. And again, it makes sense because this is like saying, please connect with a straight line every point whose y coordinate is 5. So all these points that you see on this line, there's an infinite number of points. They all have something in common between them, and that is their y coordinates are equal to 5. So this is like saying, connect all the points. I don't care what the x coordinate is. That's why I don't have any x in this equation. But they must have their y equal to 0. Y is equal to 5, the y coordinate. Similarly, imagine now that you have a straight line that's parallel to the y-axis. Now the slope of this line, well, it's a very high slope, right? It's like a cliff. It's very difficult to climb this. And not only that, this line being parallel to the y-axis, the x never changes. So how are we going to find the slope? It's the change in y over the change in x. Now, if over the change in x, the denominator 0 because there's no change in x. This line has got an undefined slopes. Now, we have seen for this line how to deal with a line, how to write the equation of a line with 0 slope. This term becomes 0. Now, this is undefined slope. The slope is not defined because you are having a fraction in which the denominator is 0, the change in x. So how do you write this down as y is equal to undefined times x plus b? That's a cause of worry, right? But if you again think of this from this perspective, like I showed all these points on this line, let's say this point is 3, 0. It cuts the x-axis at 3, 0. Now think about every point on this line. they have something in common. Can you tell me what is it? The thing is, they all have their x coordinates as 3. No matter what the y is, the x is 3. 3, 3, 3, 3, 3. Everything has got an x coordinate of 3. So we end up writing the equation of this line as x is equal to 3. There's no y in this equation. Now, if you compare this equation with this, now it doesn't make sense. You kind of get confused. Where's the y is equal to mx plus b in this? Well, there's no mx plus b. This just means that connect all points whose x coordinates are equal to 3. So this is what you need to keep in mind. This one and this one, they're important. So if you see y is equal to a constant, you know it's a line that's parallel to the x-axis. If you see x is equal to a constant, it's a line that's parallel to the y-axis. Now that constant could be anything. That could be a positive, negative fraction, and that will decide the position of that line. So for example, if this were not a plus 3, if this were a negative 3, that line would be over here. If this were instead of a 5, if this were a 0, then it would mean it's the x-axis, y is equal to 0. And to add to that, to easily help identify equations, notice that for a line that's parallel to the x-axis, there is no x in the equation. No x means parallel to the x-axis. This equation has got no y in it, so that's parallel to the y-axis. So no y in the equation means the line is parallel to the y-axis. With this on our mind, I think we can dive into the problems. So number 1, a is 0, b is 3, c is 1. What's a, b and c? ax plus by plus c. So write a linear equation. First we need to write this equation. So we have ax, that is 0x. 0x is 0. So we just have by. b is 3. So we have 3y. There's no x. 3y is equal to c. And c is 1. Now what does this tell us? There is no x in this equation. And as you can see, no x means it's a horizontal line. So we need to comment whether the equation represents a horizontal, vertical, or neither. So no x in the equation, it's a horizontal line. Take a look at this. A is 5, so we have 5x. B is 0.1, so we have 0.1y. And C is 4, so we have 4. Now in this equation, there is both x and y. So then it's neither horizontal nor vertical. So write neither. I hope that this makes sense to you now. Number 3, a is negative 1/2. So we have negative 1/2 x. B is 0. So by becomes 0y. So there's no y is equal to 14. There is no y in this equation. So no y means it's a line that's parallel to the y-axis or a vertical line. Done. Let's take a look at this question. Create a table of values for the function y is equal to 3x minus 4, pretty much like we did over here. When x is 0, y is equal to 3 times 0 minus 4, that's negative 4. When x is 1, y is 3 times 1 minus 4, that's negative 1. And when x is 2, y is 3 times 2 minus 4, that's 2. Notice that this is an equation of a straight line of the form y is equal to mx plus b, where m is 3. That means every time x goes up by 1, y is supposed to go up by 3. And that's exactly what we find over here on this chart. X going up by 1 plus 1 plus 1 and y going up by 3. Now what else do we need to do? Then grab the function, making sure to label the axis as shown in the scale. Fine. So we can start at 0 and we can label the axis as 1, 2, 3, 4, 5 and so on. On the other side, -1, -2, and so on. I leave it to you. On the y-axis, let's do 1, 2, 3, 4, 5, and -1, -2, -3, -4, and so on. Okay, so when x is 0, y is -4. Which point is it? It's this point. Another way to look at this is, this b is -4 and b is nothing but the y-intercept, meaning the point at which the line will cut the y-axis. That's -4. Okay, when x is 1, y is -1. When x is 1, y is -1. When x is 2, y is 2. When x is 2, y is 2. So if we were to connect these 3 points, it would pretty much look like this. And as you can see, they all fall on a straight line. You could connect them with a straight line. And this equation tells you that it must be a straight line because it is of the form y is equal to mx plus b. Let's move on to the next page then. Take some time to read through the problem. I have already read it. Now it says that there are two friends, friend A and friend B. Friend A, no matter what, gets the same fixed salary every year, and that's $50,000. The salary is the y, and the number of hours worked is x. So you see this x over here? It's like saying friend A works for 0 hours. What is his salary? If it's a she, I guess. If she works for 1,000 hours, what is the salary? 2,000 hours, what is the salary? Well, it's given that no matter what, friend A gets the same fixed amount. That's $50,000. So we can write this as 50. I'm just going to shorten it, write 50K instead of 50 with 3 zeros after that. So that's 50K, 50K, 50K. So it's a constant function, meaning that no matter what x is, the y's keep the same. They are all 50,000. So what would you predict if you were to plot these points on a graph paper? X is 0, y is 50, x is 1000, y is 50, 50,000 in fact. X is 2000, y is 50,000. They're all 50,000. So what we have learned from here is y is constant is a line that's parallel to the x-axis. It's a horizontal line. It means that all the points have got the same y coordinate. And this is exactly what's going to happen. Are we supposed to graph them? Write an equation for each person. Well, the equation for friend A will be simple. Y is equal to 50,000. That's it. Just like we have y is equal to 5 for this line. This line is going to be way above this. Well, we can use suitable scales. We could say that each unit on the y-axis represents 10,000. So we have 10,000, 20,000, 30,000, 40,000, 50,000. So it's pretty much going to be a line that's 10, 20, 30, 40, 50. So it's going to be this line. This is the line for friend X. What about friend A? What about friend B? Friend B actually gets paid $20 an hour. So friend B has to work hard in order to earn her money. So if friend B were to work 0 hours, she will not get paid. Simple as that. If she were to work 1,000 hours, she would get 1,000 times 20. That's $20K. If she were to work 2,000 hours in the whole year, she would get 2,000 times 20. That's 40K. So then what's the equation for this function going to be? Friend B. Y is the salary given. The salary actually is 20, the hourly rate, times the number of hours, which is x. So y is equal to 20x is the equation. Notice that this is still of the form y is equal to mx plus b. The only difference is there's no b at all. That means b is 0. Or in other words, this graph will cut the y-axis at the point 0. It's neither going to be above nor going to be below. Why? Because y in this case is the salary. So this amounts to saying that if you are not working, you don't get any salary. As simple as that. And if you were to again use the same scale, 10,000, 20,000, 30,000, 40,000, 50,000, and then even along the x-axis you have 1000 towers, 2000 towers, 3000 towers, 4000, 5000 towers. So then for 1000 towers it's 20. So for 1 it's this point. For 2000 towers it's 40. So for 2 it's going to be, I believe it's this point. So if you were to connect these points, you will see that you get a straight line. And that's what you would expect, because this equation is of the form y is equal to mx plus b. Okay, over to our last page then. If you've paid attention to the first part of the video where I've explained all of this should be a piece of cake for you. Tell whether each of the following equations represents a linear function. Number 8, y is equal to x squared plus 3. So it's not x to the first, so this is not a linear function. Number 9, 3x is equal to 4. Now if 3x is equal to 4, we see that the power of x is 1 and there's no y. So it's pretty much of this form. So you can actually solve for x by dividing both sides with 3. You get x is equal to 4/3. This is x is equal to 3. And this is x is equal to 4/3. So pretty much a line that shoots up a vertical line. Typically, we don't call this a linear function, even though this gives a straight line when graphed on the graph paper. Because this is not of the form y is equal to mx plus b, we don't call this a linear function. So I'd write a no here, but you want to check with your teacher. Your teacher might say that, okay, because this still gives you a straight line, you should call it a linear function. So do as your teacher says. I'll go with a no. I'll just stick to this definition of a linear function. Y is equal to mx plus b. Number 10, y is equal to 1. Y is equal to 1 is pretty much like this. Instead of y is equal to 5, we have a straight line below this. That's y is equal to 1. Now this is what we call a constant function, meaning the value of y is constant. It's not changing. It's always 1. So again, it isn't a linear function. But then your teacher might say that because it gives a straight line, nevertheless, you should call it a linear function. Do check with your teacher. Number 11, no problem with this. 0.3x plus y is equal to 2. So if you solve for y, you take this whole thing on this side, it will be of the form y is equal to mx plus b. The power of x is 1, the power of y is 1, and they are both present. So this is a linear function. Number 12, we see there's an x square in this equation. So then this cannot be a linear function. Number 13, y is equal to x. Well, if you think about this, m is 1 and b is 0. If m is 1, you have y is equal to 1x plus 0. That's y is equal to x. So this indeed might not look like, but this indeed is of the form y is equal to mx plus b, where m is 1 and b is 0. So this is a linear function. So that's it. That was all about your homework. I hope you take some time to understand the concept so that you can solve some problems on your own. Thank you.